A few months ago, the highly anticipated SD3 medium model splashed cold water on eager users with its poor full-body images and restrictive license. Following this, key former Stability AI team members founded Black Forest Lab, launching the powerful Flux model, which quickly overtook SD as the leading open-source image generation model. Now, Stability AI has returned with the new SD3.5 Large, aiming to restore SD's reputation. Will it succeed? In my view, SD3.5 and Flux are two distinct models with unique strengths. Due to differences in training methods and datasets, each has its advantages and disadvantages. Leveraging both together can help maximize their strengths. Today, I'll start by explaining and demonstrating SD3.5 Large's strengths, then show how Flux can address its shortcomings, and finally compare the two models across different dimensions. Opening the SD3.5 release page, the first image is of a woman lying down. When SD3 Medium was released, this prompt generated strange anatomy, leading to widespread criticism. By showcasing this image, it seems SD3.5 is now more confident in generating human bodies. Next is a reflection on SD3's license issues, now encouraging sharing and commercialization at all workflow stages, fine-tuning, LoRa, optimizations, applications, or artistic creations. Currently, SD3.5 Large, an 8 billion parameter model, is slightly smaller than Flux.1 Dev's 12 billion parameters, with a 1 megapixel resolution limit, a bit low, honestly. There's also the SD3.5 Large Turbo, a faster, slimmed-down version that generates images in just 4 steps. A 2.5 billion parameter SD3.5 Medium model will also launch later this month, with reduced VRAM requirements. The model supports diverse outputs, with various skin tones and facial features, and includes multiple visual styles like 3D, photography, painting, and line art. Official comparisons highlight its superior prompt adherence, though its aesthetic appeal slightly trails Flux.1 Dev. The license for this new version has been clarified. For non-commercial use, it's unrestricted. For small-scale commercial use, under $1 million in annual revenue, it's still unrestricted, and generated images are freely usable. This is far less restrictive than Flux's license, which could encourage some healthy competition with Black Forest Lab. Comfy UI also supports it right out of the box. Simply update Comfy UI to the latest version, download the model and place it in the models/checkpoint folder, then download the clip to models/clip. If you've used SD3 or Flux previously, most clip files are likely already in place. Both ComfyOrg and Stability AI provide workflows with minor differences, mainly around the model sampling SD3 node, clip selection, and negative prompt nodes. I combined these into a new workflow, which I'll demonstrate and share with everyone today. Opening Comfy UI, I load my merged workflow. The default uses SD3.5 Large, with clip set to clip_G, clip_L, and T5_XXL. The VAE comes with the SD3.5 model, with no need to adjust any parameters. After running it, the signature Comfy UI bottle appears after a short wait. The workflow works fine, so let's look at the nodes and parameters in more detail. Of course, testing based on a glass bottle isn't very informative, so I'll fix the random seed. Adjust the prompt to describe a beautiful woman with green eyes, dark red lips, fair skin, and black hair, and set the output size to 1216 by 832. Running this, we get a sharp-eyed, fair-skinned woman with red lips, remarkably lifelike. If there's any nitpicking, her skin texture is a bit too flawless, and her hair lacks some layering and randomness. Overall, though, I'm quite satisfied with this quality. There are a few noteworthy nodes in this workflow. First, the model sampling SD3 node, which I discussed when explaining SD3. Theoretically, the higher the value, the more it emphasizes structure. Lower values prioritize detail. It can range from 1 to 15, though I prefer 2 to 6. I'll show you the differences when the shift ranges from 0.5 to 15 with the same parameters. You don't have to stick to the default of 3, feel free to experiment when generating images. Let's take a closer look at the sampler node. SD3.5 doesn't require many steps, 30 steps are sufficient regardless of whether the sampling method is DPM, or Euler, with little change beyond that. As for CFG, unlike Flux where a value of 1 is consistently used, I suggest using a range between 3.5 and 6.5 here. Too low can stray from the prompt, while too high might cause overexposure. SD3.5 allows for a wide variety of sampler and sampling method combinations, most of which yield decent results. I recommend DPM, or Euler combined with SGM_uniform for the most stable output. In the workflow provided by Comfy.org, there's a specific configuration for loading different clip combinations. As some in the community believe that using only T5XXL produces better images. Let's test that out. Since the previous image was generated using all 3 clips, let's duplicate the workflow nodes, one with clip_L plus clip_G only, and another using T5XXL alone. After running it, we can compare the 3 images. Without T5XXL, the model struggles to produce red lips, and in the T5XXL only image, the hair appears slightly blurred. In my opinion, it's best to retain all 3 clips. Similar to Flux, this model also has FP8 and GGUF formats, allowing smaller GPUs to experience SD3.5's image generation capabilities. Let's remove unnecessary nodes and switch the model to the FP8 format. I'll group these changes, label the original image generated with the large model as large, and add a save image node labeled FP8. Running it. The images are nearly identical, so the FP8 version should work just fine. If the FP8 model is still taxing on your GPU, you can switch to the GGUF model. Add an unet loader, GGUF. Select the Q8_0 model, and add CCCLIP loader, GGUF, and load VAE nodes to integrate them with the workflow. After labeling this output, run it. It's practically identical to the previous 2 images. Since the GGUF loading nodes are set up, let's test the Turbo Large GGUF model. Turbo is a speed-optimized model that generates images in just 4 steps, ideal for real-time drawing. Set the steps to 4, the CFG to 1, and run it. It's fast, but doesn't quite match the large model's quality. Now let's try the non-GGUF Turbo Large model with the same parameters and see the same results. I still prefer the large model over Turbo. Next, let's test the large model's support for high-resolution images. Remove extra nodes, switch back to the large model. And set the resolution to 1824 by 1248, about 2 megapixels. Adjust the steps to 30 and CFG to 5.5, then run it. The result is disappointing, it's pixelated and blurry. To confirm this is a resolution issue. Reset the width and height to 1216 and 832, which stay just under 1 megapixel. After adding an image node, I run it. And it works fine. Suggesting SD3.5 Large doesn't support direct high-res output. Can we create a smaller image and then upscale it? Add an Ultimate SD upscale node to the workflow. Connect it. Add the upscale model. Match the parameters to K-sampler. And add a Save Image node. After speeding up the process, the result shows blurriness and ghosting artifacts. When SD3.5 Large was released, some speculated that it would overshadow Flux, but I think, why choose when you can have both? They're different models that can work together. In the upscaling workflow, since SD3 struggles with high-resolution images, why not switch to Flux, which can handle large images seamlessly, add the relevant Flux generation nodes and connect everything. Be sure to update the Ultimate SD upscale node parameters according to Flux requirements, setting CFG to 1 and using Euler plus beta for sampling. After adding an image node and running it, the upscale result looks great without any issues. Of course, you could use Tile to split the image and have SD3.5 upscale each part, but I find this approach much simpler. Unlike Flux, SD3.5 has the advantage of supporting negative prompts, so let's put this to the test. After removing the extra nodes, here's how I typically test negative prompts. I enter basket full of fruit in the positive prompt to generate a basket of fruit. Looking at the image, we can see grapes, apples, and more. Now, I add grape to the negative prompt and run it again with the same seed. The grapes disappear from the basket, confirming the negative prompt is working. If you find the negative prompt effects to be weak, consider disabling certain nodes. These restrict the negative prompt's effect to the first 10% of sampling. However, the later they end, the more they impact image quality. So adjust based on your needs. Compared to SD3, SD3.5 has made substantial progress in understanding human anatomy, enabling it to generate full-body images more accurately without awkward poses. However, it still struggles with the finer details of hands and fingers. Let's clean up the workflow, remove unnecessary nodes, and adjust the positive prompt to show a woman holding her hands up to the camera. Remove the negative prompt. Change the resolution to 832 by 1216 and run it. It's clear that this woman's hands each have an extra finger. Flux excels at hand correction, so we could add face detailer to detect and redraw the hands automatically. Today, however, I'll take a shortcut. I'll add a Flux IMG to IMG process. Use load image to bring in the previously generated image. Adjust parameters as required by Flux. And set a lower denoising strength at 0.6. I'll then paint over the areas that need redrawing. Save the mask and run it. The woman's hands are restored with ease. One nice feature of Flux is its support for various non-standard resolutions. Can SD3.5 handle this too? Let's clean up the workflow, delete unused nodes. Change the prompt to describe an ocean view. And set the resolution to 1920 by 208. After generating the image, it doesn't show any artifacts, but the quality falls short of Flux. I'll show a comparison. Let's try another unusual resolution with a vertical cat image, 400 by 1600, and compare the results with Flux. Both images of the cat are quite good, showing minimal difference. It appears that SD3.5 can handle these special resolutions too, though more attempts might be necessary for optimal results. Next, I'll load a comparison workflow I created. The upper section is SD3.5, and the lower is Flux, with shared parameters on the left: positive prompt, resolution, and seed. This setup allows us to directly compare SD3.5 and Flux in terms of preferences and differences using the same prompt. For a classic prompt I frequently use, I'll generate 3 flower pots with roses, daisies, and sunflowers in red, white, and yellow, respectively. Each flower also has a name label. This tests image generation, text generation, and spatial awareness. To keep it fair, each model generates 3 images. After running it, we get 6 images where the flower types and colors are accurate and in order. While SD3.5's third image is a bit blurry and Flux's first lacks a label, the other images demonstrate their capabilities. When unsatisfied, trying again should yield quality results. I selected a range of application scenarios with prompts generated by large language models or shared by the community to further compare SD3.5 and Flux. This prompt describes a complex visual art scene involving 4 specific artists. When using SDXL, people discovered its ability to recognize and generate images in various artist styles, with someone even creating an online gallery to showcase this. As an upgrade, SD3.5 inherits this capability as well. Flux, however, likely didn't train on this content, so it attempts to illustrate the scene from the prompt but lacks the distinct artistic style found in SD3.5's output. The next prompt generates images resembling everyday photos. Flux's images look like professional photography, often with depth of field, while SD3.5's images resemble casual snapshots taken by friends. Both have their strengths. Testing a model's ability to create a PowerPoint slide is a great way to assess its text generation abilities. All 3 of Flux's images appear in the form of presentation slides, while SD3.5 produced 2 that look like standard PPT slides. Both models adhered to the prompt, so let's focus on text accuracy. Flux nailed all 3, while only one of SD3.5's images was correct, giving Flux a slight edge in text precision. Now, let's generate a Van Gogh-style landscape painting. Both models display distinct characteristics. Flux's images are vibrant, with more pronounced colors and details, though they lack the thick, textured brushstrokes characteristic of traditional oil painting. On the other hand, SD3.5 captures the rough texture associated with traditional oil paint, making it closer to classic oil painting techniques. Next, a cartoon portrait in marker style, perfect for avatars. Flux's version is cuter, though it misses the colorful hair in the prompt, while SD3.5's image is done in a completely different art style. Which one do you prefer? I'll stop here, but feel free to try the workflow yourself and explore these results. SD3.5 and Flux have raised our expectations for large models. There was a time when it was challenging to understand spatial relationships in prompts, generate text, or create images in specific styles, tasks requiring tools like LoRa, ControlNet, and IP adapter. Today, they're basic features. We can select the model to be used according to different requirements. SD3.5 excels in everyday photography. Varied art styles, adherence to prompts, support for negative prompts, and faster generation. Meanwhile, Flux has strengths in generating human figures, text accuracy, and high-resolution images. Overall, Flux remains the more versatile choice. However, SD3.5, as a foundational, non-distilled model, is highly customizable and has a different cross-attention architecture that makes it more IP adapter-friendly, though. Unfortunately, we won't see a pony model. As users, there's no need to pit one against the other, why not both? I look forward to even stronger versions of both the Flux and SD series. That's all for today's video. If you're interested in the workflow, models, or comparison images, check the links in the description. See you next time.